Alright, hi guys. Today what we're going to be talking about is isotopes and average atomic mass. So, jumping right in. What I want to draw your attention to is these three cars. Okay, now you're going to notice that these may be slightly made up cars, but what they are. Okay, this is the Bananamobile. Okay, and we have three different models of the Bananamobile. Okay, this first one, the Bananamobile SE. Okay, you're going to notice that, it's a nice banana yellow color, okay, shaped just like banana. Now, some of the features of the Bananamobile SE is, it's got a standard tape and radio, it has a CD player, it has its power locks, power windows, that kind of stuff. But if you want to spend a little bit extra money, you can get the Bananamobile XL. This comes in the nice cherry red color that you can see right over here. Also, this has the 6 CD changer, and just some other kind of nice stuff, maybe the full navigation system and everything else. Then, you want to spend even more money, you have the Bananamobile XLT, okay? This comes in the very nice royal blue color, as well as having, the leather interior, it's a really slick ride. So, we're looking at these three different vehicles. They're all Bananamobiles. And what makes them a Bananamobile is this unique banana shape. Okay? And all three of them have it. And the same way that, your different cars have different models, well, that's the same thing that's going on with these Bananamobiles. Now, the reason that I talk about this is that when we're talking about isotopes, okay, it's the exact same thing except we're dealing with atoms. Okay, so an isotope are atoms of the same element that have different masses. Okay, all isotopes of a particular element have the exact same number of protons and electrons, but they have different numbers of neutrons. Now, I'm going to move this over here. Okay, you can pause this and you can look at it a little bit more. I'm just going to get it out of the way and show you an example of what I'm talking about. Okay, so what I have here is three different carbon atoms. Okay, these are all isotopes of each other. What I want to show you is the similarities between these three different isotopes of carbon and our three different Bananamobiles. Okay, we have carbon with a mass number of 12, carbon with a mass number of 13, carbon with a mass number of 14. Now, guys, just like the Bananamobiles, these are all carbon atoms. But kind of like we have the Bananamobile SE, the Bananamobile XL, and the Bananamobile XLT, they're different versions or different models of that same vehicle. In this case, different versions or different models of the same element, carbon. Alright, now if you remember, this number right there is the mass number. And what that number is it is protons plus neutrons. Okay, so we know that carbon, and this is going to be the same for all three of these, is going to have 6 protons. The reason we know that is, guys, if you look at your periodic table, okay, I'm going to show you this one up real close so you can see it. Okay, carbon's right here. Now, I know this kind of looks backwards, but if you look really close, okay, that's a number 6, right? There's a 5, 6, 7. Carbon is number 6. Well, what that means is that carbon has 6 protons. Alright? And if the mass number is 12, 6 protons plus a sum number of neutrons is going to equal 12. Well, guys, our basic math doesn't fail us. It sure is not going to today either. Well, 6 plus 6 neutrons is how many we have in carbon 12. Okay, carbon 13, because it's still carbon, it's still going to have 6 protons. But this time, we need these two numbers, okay, these two things, protons plus neutrons, to equal 13. Well, again, 6 plus what equals 13? In this case, 7 neutrons. And we do the same thing with carbon 14. Okay, because it's carbon, it's still 6 protons. Well, 6 plus 8 neutrons is going to get us to 14. Okay, so again, we're looking at the similarities. All of our Bananamobiles, they're Bananamobiles because of the unique banana shape. All of our carbon atoms are carbon because they all have 6 protons. Now, what makes them different is, in the case of our banana mobiles, okay, the paint color, right? Remember we talked about this just having a standard radio. Our banana mobile XL had that, you know, the 6-disc changer in there, and then this has the leather interior and all that other stuff. Well, for our carbon isotopes, okay, they have different numbers of neutrons. Okay, and they're the exact same thing as different properties, you know, it just means that they weigh a different amount. Okay, so that's what we're talking about when we're talking about isotopes. Okay, it's isotopes of the same element because they all have the same number of protons, but they're going to weigh a different amount. Okay, these are all different weights because they have different numbers of neutrons. Okay, so in a nutshell, that is what an isotope is. Alright, oh man. Let's kind of split up some of those things and get those going. Alright, there we go. Let's get rid of this. There we go, gone. Okay, now the only other thing that we're going to talk about today is average atomic mass. So, average atomic mass. Now, what the average atomic mass is, and I'm going to go through the definition, I'm not going to write it down, so you may need to rewind this a couple times to get it, but the average atomic mass is the weighted average of atomic masses of all the naturally occurring isotopes of that element. Okay, I'll say it again. The average atomic mass is the weighted average of the atomic masses of the naturally occurring isotopes of an element. Alright, now, that's just kind of a whole big jumble. Basically what it means is, just like with weighted grades, if you have more of a certain isotope, well then it's going to be closer, or the overall weight is going to be closer to that amount. Alright, so let's give you an example. I think that'll really help it out. Here's the rest of our equation, though. It's going to be mass of isotope number 1 times the percentage of that isotope plus mass of isotope number 2 times the percentage of that. And we're going to do that for as many different isotopes as we have. Alright, so let's get that small and we'll kind of put that up there. Alright. Here's going to be our example. So if we have 2 isotopes of carbon,
hey guys,
we have carbon,
and on today's video, the objective will be
12, and carbon 12 makes up 90% of all of the carbon that's there, and we have carbon 14. Okay, and carbon 14 is going to make up 10%. So this is going to be our problem, and we're going to try and find the average atomic mass of these 2 isotopes of carbon. Well, if we think about it, because there's more carbon 12, okay, let's take a look at that. There is 90% of the carbon in the world is going to be carbon 12. Well, then we would assume that our weighted average means that most of the weight is going to be close, or most of the carbon atoms are going to be carbon 12 atoms, and only a small percentage, in this case 10%, is carbon 14. Well, instead of just adding those 2 things together, instead of doing 12 plus 14 divided by 2 and getting 13, well, that would be saying that if we randomly grabbed 2 carbon atoms out of a bucket of carbon atoms, that one would be carbon 12, one would be carbon 14. Well, we know that that's not the case. Okay, for every 9 carbon 12 atoms, we'd grab 1 carbon 14. So we got to do a little equation with that. It's not too bad, pretty simple. Okay, so we're going to do the mass of number 1, which is 12, times the percentage, which is 0.90, and I'm going to use the decimal form of 90%, so 0.9, plus 14 times the decimal of 10%, which is 0.10. You can just kind of believe me on this one, but if we put it in the calculator, we get 12.2. Alright, that was kind of hard to see. Let's move that over. There you go. Okay, 12.2. And, you know, which is what we thought would happen, that we're a lot closer to 12 because most of the carbon is going to be carbon-12. So that's kind of the process for finding average atomic mass, and we're going to practice this a lot as we keep going forward.